Bismillahirrahmanirrahim. Allahumma rabbi zidni ilma. Bismillahirrahmanirrahim. Assalamu alaikum. Welcome dear students in the subject of Internet Architecture and Protocols. It's Ghulam Yasin, lecturer in Computer Science, University of Education Lahore at DG Khan campus. Dear students, in our previous lecture we have studied in detail about IP version 4 and IP version 6 header format. In this lecture we will study about IP version 4 in detail. So Internet Protocol version 4 detailed topic will be discussed in today's lecture. Lecture contents. In today's lecture we will discuss about introduction of IPv4, class full addressing, different network classes and subnet mask. We will discuss in detail about these topics in today's lecture. What is an IP address? An IP address is a 32-bit address. The IP addresses are unique. So dear students, there are 2 points which are discussed over here. First of all is IP address is of 32-bit address, and these 32 bits are in binary form, and these IP addresses are unique. If we talk about local area network, all the devices which are connected in local area network, all those devices must have unique IP address, and those IP address will be from free of cost IP addresses. And if a device is using a WAN or internet service, then that device must also have an IP address which will be unique, and that IP address will be provided by ISP on the paying of some specific required amount. IPv address space. The address space of IPv4 is 2 raised to the power 32 or 4,294,967 and 296. So as we have discussed in our previous slide, the IP address is of 32 bit. It means there are 32 bits in binary format, and if we make combination of 32 bits, there will be 2 raised to the power 32, और ये टोटल combinations हैं जो हम एक वक्त में एक स्पेसिफिक नेटवर्क में डिवाइसेस को अटैच कर सकते हैं. या अगर हम इंटरनेट की बात करें तो एक वक्त में इतनी डिवाइसेस जो आप ये कॉम्बिनेशन देख रहे हैं, जो अप्रॉक्सीमेटली 4 अरब के करीब बनते हैं, तो एक वक्त में इतनी डिवाइसेस इंटरनेट पर इंटरनेट एक्सेस ले सकती हैं. बाइनरी नोटेशन. So dear students, these are 32 bits, and IP addresses must have described in 4 parts or 4 bytes or 4 octets. So these are 4 octets, and every octet or every byte must have 8 bits. So there are 4 portions or 4 octet. So 8 multiplied by 4 is equal to 32 bits. So IP address in binary notation is described in this way, that the decimal number will be converted into binary, and every binary octet must have 8 bits, which may be 0 or which may be 1, and definitely it will be the combination of multiple zeros or multiple ones. Dotted decimal notation. Dear students, you can see an IP address in dotted decimal notation, which is 128.11.3.31. This is our decimal number, and this number is separated by dot. That's why this is called dotted decimal notation. So 128.11.3.31. When 128 will be converted into binary, you can see the binary number of 128 as well as the binary number of 11, the binary number of 3 and the binary number of 31. So the address may be in the form of decimal or in the form of binary. Hexadecimal notation. Dear students, hexadecimal is based on base 16, 0 to 15. So 0 to 9 is as it is, and the 10 is treated as A, 11 is treated as B, 12 is treated as C, 13 is treated as D, 14 is treated as E, and 15 is treated as F. So if we see about the leftmost octet, which is 0111, 0101, if we convert 0111 into decimal number, which is 7, and if we convert 0101 binary number into decimal, which is 5, so this is 75, which is hexadecimal notation. And likewise, second octet is converted into 95, third octet is into 1D, and the last is into EA, and the combined address will be 0 into 75951DEA. This will be hexadecimal number of the said binary number. Example 1. Change the following IP address from binary notation to dotted decimal notation. So dear students, you can see a binary address over here, and this binary address will be converted into dotted decimal notation, which is 129.11.11.239. So you have to use to convert a method which you have studied in the previous classes, and you can convert binary into decimal and decimal as well as into binary. Example 2. Change the following IP address from dotted decimal notation to binary notation: 111.56.45.78, and this is dotted decimal notation, and you can convert this specific address into binary address, which you can see in the solution. So you can directly convert decimal to binary using the specific method which you have studied in the previous classes. Example 3. Find the error in the following IP address: 111.56.045.78. Solution: there are no leading zeros in dotted decimal notation 045. So dear students, if the address is written in the dotted decimal notation, leftmost bit cannot be 0. Over here in the third octet, which is 045, so 0 can't be over here. So this is an error while describing the IP address in dotted decimal notation. So keep in mind that when the address is in the form of dotted decimal notation, the leftmost bit can't be 0. Example 3 continued. Find the error in the following IP address: 75.45.301.14. Solution: in decimal notation, each number is less than or equal to 255. 301 is out of the range. So dear students, every octet must be between 0 to 255. It means there are 4 portions, there are 4 octet, there may be 0 or there may be 255. 0 is minimum value and 255 is maximum value. And 301, which is third octet in this dotted decimal notation, this is greater than 255, which is not allowed. So this is an error, and 301 can't be over here. Example 4. Change the following binary IP address hexadecimal notation. As we have discussed in our previous slides, that hexadecimal notation is based on base 16, which is 0 to 15. So leftmost octet will be divided into 2 portions, and every 4 bits must be converted into hexadecimal number, and you can see the solution over here of this binary number as we have discussed in our previous slide. So you can convert easily this binary number into hexadecimal number. Occupation of the address space. So dear students, as you know that the IP addresses are divided into 5 different classes: class A, Class B, Class C, Class D and Class E. And over here you can see the address spaces are occupied by different classes. In classful addressing, the address space is divided into 5 classes: Class A, Class B, Class C, Class D and Class E. So dear students, about these classes we will study in detail in our coming slides. Finding the class in binary notation. Dear students, this is very important slide to understand how we can identify the class of IP if the address is written in binary notation. As you know that there are 4 different portions, 4 different bytes of an IP address, and just we have to see the leftmost byte, which is first byte. अगर फर्स्ट बाइट की लेफ्ट मोस्ट बिट 0 है तो वो क्लास ए। इसी तरह से अगर लेफ्ट मोस्ट फर्स्ट बाइट की 2 बिट्स 1 और 0 हैं तो वो क्लास बी, और इसी तरह से 110 है तो वो क्लास सी, अगर वो 111 है तो वो क्लास डी, और अगर वो टेट्रा 1 है तो वो क्लास ई का एड्रेस होगा। तो इस तरह से हम किसी भी स्पेसिफिक एड्रेस जो बाइनरी नोटेशन में होगा आइडेंटिफाई कर सकते हैं कि वो किस क्लास का एड्रेस है, जस्ट टू सी द लेफ्ट मोस्ट बाइट and the identification bits are in front of you in this slide. Example 5. Show that class A has 2 raised to the power 31 and the combination of 2 raised to the power 31 is equal to in front of you 2, 147, 438 and 648. So if the class A is used, then approximately these systems can be attached in a network. Example 6. Find the class of the following IP addresses. Dear students, these are 2 IP addresses and we have to identify the class. As we have discussed in our previous slide, if the leftmost byte, which is first byte, starts from 0, this is class A. So over here you can see the leftmost bit is 0. So first IP address is of class A address, and the next is 110, and we have also discussed that 110 is of class C address. So next binary address is of class C address. Finding the class in decimal notation. In the previous slides we have discussed the method to identify the class in binary notation. Now we will see how we can identify class if the address is written in dotted decimal notation. If the first byte is between 0 to 127, then the class A. If the byte is between 128 to 191, then this is class B address. And same wise 192 to 223, this is class C address. 224 to 239, this is class D address. And 240 to 255 is class E address. So this is a method to identify a class if the IP address is written in dotted decimal notation. IP address with appending a port number. Dear students, in this slide we will study a concept of socket. First point is 158.128.1.108:25. This address contains 2 portions. Left portion is of IP address, which is 158.128.1.108, but after colon is written 25, which is basically port number. What does it mean? It means that a machine, a computer which is using the following IP address is transmitting on the port of 25, or that machine is using port number 25. Second point, the 4 octet before colon is an IP address and the number of colon 25 is a port number, as just I have explained about IP address and port number. But in detail, A machine is using a specific task. A machine is using to perform a specific task, and that is on the port number 25, and the combination of IP address and port is called a socket. So in computer networking, socket is combination of IP address and port. So over here, this is socket explanation, which is in the form of IP address and port. Net ID and host ID. Dear students, in this slide we will see the concept how many bits are reserved for network portion and how many bits are reserved for host portion in every class. Let's suppose if we talk about class A, there are 8 bits for network portion or network identification and 24 bits for host portion or host identification. What does it mean? It means that using class A, we can create 2 raised to the power 8 networks or 2 raised to the power 8 labs. And in every lab, in every network, we can attach 2 raised to the power 24 systems. In class B, there are 16 bits for network identification, 16 bits for host identification. What does it mean? It means that we can create 2 raised to the power 16 labs or 2 raised to the power 16 networks in any company, and in every network or in every lab we can attach 2 raised to the power 16 computers or 2 raised to the power 16 hosts. In class C, there are 24 bits for network portion. What does it mean? It means we can create 2 raised to the power 24 labs or 2 raised to the power 24 networks in any organization, and every lab, every network contains 2 raised to the power 8 hosts. इसका मतलब ये है कि सबसे कम जो हमारे पास नेटवर्क्स क्रिएट करने की ऑप्शन है वो क्लास ए में है, लेकिन सबसे ज़्यादा होस्ट अटैच करने की ऑप्शन भी क्लास ए में है। क्लास बी में ये इक्वल है और क्लास सी में हम नेटवर्क ज़्यादा क्रिएट कर सकते हैं, लैब ज़्यादा क्रिएट कर सकते हैं, लेकिन हर लैब में जो हम सिस्टम्स अटैच करेंगे वो 2 raised to the power 8 होंगे, वो कम हो चुके हैं जब हम क्लास ए से कंपेयर करते हैं। नेक्स्ट क्लास डी, which is for multicast, and class E is reserved for future use. So these classes are very important concept in IP addressing. IP addressing में हम जब तक इन classes के network और host portion के concept को understand नहीं करेंगे तो हम IP addressing को और इसी तरह से further subnetting को understand नहीं कर सकते. So hopefully you have studied IP addressing in the previous classes in the subject of computer communication and network, but over here I'm trying to explain in detail so that you can understand what is an IP address and why this IP address is important in our networks. Class D addresses are used for multicasting. There is only one block in this class. So dear students, first of all you must understand what is multicasting. There are 3 words commonly used: unicasting, multicasting and broadcasting. So what is unicasting? Unicasting is one-to-one communication. What is broadcasting? Broadcasting is like to all, and multicasting is like specific. If we take example of your cell phone, you have 100 contents. If you will send a message or text message to one specific recipient, then this will be unicasting. And if you send the message to all recipients, to all contents, this will be broadcasting. And if you have created some specific groups, for example family, friends, and in family there are 10 contents, in friend group there are 10 contacts. So if you send a message to specific group, this is multicasting. So over here class D is used for multicasting purpose only. Class E addresses are reserved for special purpose. most of the block is wasted. Dear students, class E in IP addressing scheme is not used still. So this is for future use, this is reserved for future use, and most of the block is wasted definitely when the address is not used, when the class is not used, then the address will be wasted, the block of the addresses will be wasted. But in future, when there will be need of further class, this class E will be used. But right now the three classes, class A, class B and class C, are sufficient to fulfill the requirements of different organizations, different users. So still these three classes are commonly used, and class D is for multicasting and class E is not still used. Network addresses. Dear students, as I have told in the previous slides, that the network portion of any specific IP address identifies about the network. Over here, network addresses are used for this purpose. The network address is the first address. The network address defines the network to the rest of the internet. Given the network address, we can find the class of the address, the block and the range of the addresses in the block. So using the network address, we can find the block and the range of addresses in the block. Range mean from where the network will be started and at which address the network will be stopped. Note, in classful addressing, the network address, the first address in the block, is the one that is assigned to the organization. Dear students, if you will revise the concept of net ID and host ID, so I have discussed about network portion. In class A there will be 8 bits, in class B there will be 16 bits, and in class C there will be 24 bits. So each portion of network identification of any IP address is to identify the network address of specific block, and after that we can identify the network portion. So network ID, network identification, is used for this purpose in classful addressing. And in classful addressing, what is classful addressing? Basically, classful addressing is normal addressing scheme which is used nowadays, IP variant 4. So this is called classful addressing as well. So in classful addressing, network address is used to identify the first address in the block as well as the total assigned IP addresses from start to end. Example 8. So dear students, in this example we will see in detail about the network address and likewise block and so on. So first of all we will see about example. Given the network address 132.21.0.0, find the class, the block and the range of the addresses. First of all we will find the class. This address is written into dotted decimal notation 132.21.0.0. If you remember, when we discuss about dotted decimal notation, the range of class A was between 02 to 127, class B range was between 128 to 191, class C range was between 192 to 223, class D range was 224 to 239, and the class E range was 240 to 255. And we have studied that class D is for multicasting purpose and class E is not used, and this is for future used. So the decimal number which is being used over here is 132, and if we see, this number is between 128 to 191, which is of class B range. So we can see that this address is of class B. So in solution, first portion is the first byte is between 128 and 191, hence this is class B address. So first portion of the question is very clear. Second is the block. How we can find the block? To find the block, we have to see the network ID. Again, we have to revise the class B concept about network and host identification portion. In class B, network identification portion was dependent on 16 bits, and as well as the host identification portion was dependent on 16 bits as well. It means network identification portion in class B is of 16 bits. So if we find the block, then just we have to write the network portion of any IP address as it is. So network portion means 2 bytes which are 132.21. So 132.21 we have to write these two portion as it is. This will be the block. So second portion of this example or this question was the block. So the block has the net ID of 132.21. So this is second answer of this example. And the last one is the range of the addresses. Now we have to define the range. Range mean from where the class starting and the ending. How many computers will be attached? So you have to take the network ID which is 132.21. So you just write 132.21 and the remaining portion will be 0. Remaining portion is dependent on 16 bits, so this will be 0. So take network ID as it is 132.21 and the remaining 2 octet will be 0.0.02. Again take the block network ID as it is 132.21 and the remaining 2 octet will be all ones .255.255. तो इस तरह से हमारे जो एड्रेसेस की रेंज है कहाँ से हमारा नेटवर्क स्टार्ट होगा और कहाँ एंड होगा, तो नेटवर्क आईडी को एज इट इज लें और नेक्स्ट होस्ट पोर्शन को 0 कर दें और जो एंडिंग रेंज है उसमें नेटवर्क आईडी को एज इट इज लें और होस्ट पोर्शन को ऑल वंस कर दें. सो जो रेंज होगी दैट विल बी 132.21.0.0 to 132.21.255.255. The network address is the beginning address of each block. So dear students, each block is started by network address. Whenever we'll see any IP address, the leftmost portion will be network identification or network address portion. It can be found by applying the default mask to any of the address in the block including itself. What is default mask? We will study in our next and last slide. So default mask is used to identify the network address as well. It retains the net ID of the block and set the host ID to 0. As in the previous example we have seen that the network ID must be as it is and the host ID will be 0. So in the previous slide you can see that the network ID of class B address was 132.21 which must be as it is and the host portion will be 0 which is .0.0. So this will be 132.21.0.0, but the identification of network address will be on the basis of left 2 octet which is 132 and 21. Default mask. Dear students, in our classes concept we have seen that in class A network identification portion is dependent on 8 bits and the host identification portion is dependent on 24 bits. While we have to use default subnet mask, just we will change the network portion in all ones and change the host portion in all zeros. So you can see over here the network portion of class A is 255 and the host portion is dot zero dot zero dot zero. Same wise, in class B, the network portion was dependent on 16 bits and the host portion was dependent on 16 bits. So in default subnet mask of class B, you have to convert it 16 bits in all ones and 16 bits in all zeros. So left portion, which is network identification portion, all bits 1 will be 255.255 and the host portion all bits will be 0, so dot 0 dot 0. And likewise in class C, you know that the network portion was dependent on 24 bits and all these bits are 1, so this will be 255.255.255 and the host portion will be dependent on 8 bits and all these bits are 0, so there will be dot 0. So while defining default subnet mask, we have to change network portion in all ones and we have to change host portion in all zeros. In dotted decimal, this will be 255 and 0. 255 for all ones and 0 for all zeros. So class A default subnet mask is 255.0.0.0. Class B default subnet mask is 255.255.0.0 and class C default subnet mask is 255.255.255.0. So dear students, thank you very much for your concentration, for your learning, for your passion. I hope best of luck for all of you always.